So I could count the cubes in that structure to figure out the volume. If I count them, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I count all the cubes, I get 12. However, counting cubes isn't always the best or most efficient method. Another way I can think of volume is thinking about it in terms of layers. So I'm going to look at this structure and I'm going to think, how many layers do I see? Right now I see 2 layers. I'm going to make my line down the middle. I see 1 layer in the front and 1 layer behind. So on the front I have 1, 2, 3, 4, 5, 6. And I have an identical layer in that back. So there will be 6 on that side. So I have 2 layers. Each of them had 6 in them. So I have a total of 12 cubic centimeters. Because 2 layers of 6. And we all know of means to multiply. Okay? But maybe I can see this in a different way. I looked at the front of the structure, but how else could I split up this structure so I could easily count volume in a different way? How about we look at the top? If I look at the top of my structure, I have 1, 2, 3, 4, 5, 6. I have 6 cubes on the top. And that means there's how many cubes on that bottom layer? 6. So I have how many total layers? 1 on the top, 1 on the bottom. So I have 2 layers of 6. And once again, my volume is going to be 12. But is there any other way I could find the volume by looking at layers? Let's see. We seem to be looking at the surface or the face of this structure. So we looked at the front face, we looked at the top face. So now let's look at the side face. How many cubes, that was a bad line, are on this side? We have 1, 2, 3, 4 cubes. 4 cubes on the side. And if I keep going back, how many layers am I going to get? 1 layer of 4, my second layer of 4, my third layer of 4. So I have 3 layers of 4 cubes, which makes how many total? 12. So no matter how many layers I have, no matter how many cubes are in the layers, I keep getting 12 for the same structure. Let's try another one.